Good morning, boys and girls. So today I have a couple questions for you to think about this morning. And my first question is, which is heaviest, 1 pound of gold or 1 pound of feathers? Now this is actually a trick question because the feathers and the gold would weigh the same amount since they're both 1 pound. A follow-up question I have is, if you had 2 boxes, both of the same size, and you filled one with gold and one with feathers, which would be heavier? Now in this scenario, the box with gold would weigh more. One of the reasons for this is that the box filled with gold is more compact. So we're going to do a little experiment today, and for this experiment we're going to look at which objects sink and which objects float. So I have collected 20 objects for us to look at, and as I'm doing this, I just want you to think about why certain objects sink and why certain objects float. So I'm going to move you a little closer so you can see what I'm doing. And I'll make sure to say which object I'm putting in and whether it sinks or floats, just so in case you can't tell in the video, you know what's going on. Okay. So for my first object, it is a clementine. And this object does float. My second object is a pair of nail clippers, and this object sinks. My third object is a little thing of dental floss, and this floats. For my fourth object, we're going to be doing a hammer, and I want you to look closely at what happens when I put the hammer in the water. So I'm not sure if you can tell, but the top metal part of the hammer actually sinks into the water, and the handle that is wood floats. And then I have a marker, and that floats. I have a cucumber, and I want you to think about, make a prediction what you think would happen if I put this in the water. Do you think that a cucumber would sink or float? So it floats. And I want you to think about why a cucumber would float even though you might think that it would sink. A pair of scissors, that sinks. We have a pencil, which floats. We have a little K-cup to make coffee with, and that floats. A measuring spoon. Now something interesting happened with the measuring spoon because it actually took a little bit longer to get to the bottom, but it did sink. We have a little bottle of perfume, which sinks. We have an Easter egg that has nothing inside, and that floats. A butter knife sinks. Now this is another interesting one because it's pretty light, so I want you to think about what's going to happen whenever we put the comb into the water. And that, similar to the measuring spoon, sinks down to the bottom, but not as quickly as the metal items did. We have a little tube of mascara, which floats. A little light bulb, and that sinks pretty quickly. A quarter sinks. We have a seashell, which sinks. A little thing of chapstick, which floats. A battery sinks. And finally we have a pair of tweezers, which sinks also. So I'm just going to put these items back. Okay, so now that we saw that some of those smaller items actually did sink in the water, I want you to think about how it might be possible for a large ship to float whenever it's sailing in the ocean. And part of this, we're going to be learning about a famous ship that actually ended up sinking, which is called the Titanic. So to do this, we're going to go to this website and scroll through and learn some facts about the Titanic, and then we're going to do a little explanation of how this all relates to each other. So some of you might have heard of this luxury ship before, which sadly ended up sinking after hitting an iceberg on April 15, 1912 during its first voyage. So this ship was built to take a trip across the Atlantic Ocean. It took 3 years to build and cost $7,500,000, which is equivalent to about $400 million today. The Titanic was built and launched in Belfast, Ireland. It ended up being launched on May 31st, 1911. And on April 2nd, 1912, it sailed its voyage across the Atlantic. This journey was meant to take 137 hours. And to get a better visual of what the Titanic might have looked like, it was almost as long as 3 football fields and as tall as a 17-story building. So it was pretty big. It had 4 smokestacks on top, and one of those was actually just included for decoration to give the ship some balance. The ship consisted of 840 rooms, 9 decks, and 10,000 light bulbs. To ride on the Titanic, a first-class ticket would have costed you $4,350. A standard class ticket would be about $1,750, and a third class ticket costed $30. And you have to keep in mind whenever we're thinking about this that prices were a lot different back then, so this would have been a lot more money at the time than it might seem to us right now. The Titanic could carry about 3,547 people when fully loaded. And when it sank, the total number of survivors was around 705. 492 of those passengers were from the first class, and about 215 were crew members. So on board, the Titanic was able to carry 75,000 pounds of fresh meat, 36,000 apples, 40 tons of potatoes, 1,000 loaves of bread, and 10,000 pounds of sugar. On April 14, 1912, the Titanic received warnings of icebergs around the area that it was sailing to, and it ended up crashing into one of the icebergs, which caused it to sink. But we're going to learn a little bit more about why certain objects sink and float and what happened specifically with the Titanic that caused it to sink. So we're going to go back to our PowerPoint. So for this part of my lesson, I'm just going to be recording the screen as I explain it so you can see the PowerPoint better. Now when we're thinking about sinking and floating, a word that we need to remember is density. Basically, density is how compact an object is. So when we were thinking about the question from earlier about the 2 boxes, one with feathers and one with gold, one of the reasons that the gold would be heavier is because it is more compact or dense. Now the denser an object is, the less likely it is to float. So when we look at this image, it helps us to visualize what density really means. A high density object would be the particles packed closely together with not much space in between, and low density would be the particles loosely packed together. So an easier way to think about it would be that something that floats means that it is less dense than the water, and something that sinks means that it is more dense than the water. Now I'm going to have some objects appearing on the screen, and I want you to tell me or think about whether they would sink or float. So we have a hammer, a watermelon, an apple, an anchor, and a pencil. Now we saw some of these objects in my demonstration earlier. We saw that the hammer in water, the top metal part sunk and the handle floated. So the reason for this is that the metal part is more dense and that part would sink in the water. But wood is less likely to sink because it is less dense, so the handle floated. And same with a wooden pencil. This floated in the water because it is less dense than a metal object like an anchor would sink. And a watermelon would be a surprising one because we would think since it's bigger and heavier that it would sink, but it actually floats because the center of a watermelon is not dense, and same with an apple. So thinking about how ships are able to float, we have to think about something called the buoyancy force. And what this basically means is that as a ship pushes out water, the displaced water, which is the water that it's pushing out, would push the ship upwards. So if we look at this graphic here, we can see that gravity is pushing down on to cause the density of the boat, but the buoyancy is pushing up on the density of the water, which basically equals them out and allows for the ships to stay afloat. So relating this to the Titanic and why did the Titanic sink? We know that it was caused by a collision with an iceberg, but what happened was this damaged the watertight compartments on the ship, which are created so that water is not supposed to be able to get in or escape. And basically these compartments filled with water, causing the bow, which is the front of the boat, to sink. We can see that in this image here, that as the bow filled with water, it sank and broke off from the back end of the ship. So the Titanic and density. I have a short video for us to watch which goes into more depth about why the Titanic sank.
I write pretty much all day. 15 years now, let's make it 23 degrees.
Oh, absolutely.
Okay.
I'm happy to do it. Yeah.
All right, let's put this to bed.
There we go.
All right, that looks good. Ship's veering to port, going 22 knots. Sideswipes the iceberg. Murdoch ports around the iceberg, try to keep from hitting the propellers. That looks pretty good. Okay, so now we're watching an accelerated time. We see the first 5 compartments flood. They equalize pretty quickly. Bows pulled down. We see the port list. Port list looks right. That looks like about 9 degrees. Well, you can really see the effect of that list on the flooding. So yeah, superstructure starts to get pulled under. Funnels collapse at their base. Now the bow is accelerating downward. That looks good. We're starting to see the stern come up. We got our maximum peak stress, and yeah, boom, it breaks. Okay, bow swinging down. That looks good. The double keel hang on, and then they separate. Bow plunges straight down. All right, you got mast snapping back. The funnels are ripping backward, pulling off all the davits. Bow's going down like a torpedo. Here's the angle when it falls through into a stable position. Let's see the stern. Heeling way over to port. That looks right. And she goes, yep, that's right. She goes almost vertical just when she goes under, and then boom, implodes. Now she accelerates, and all the stuff starts to rip off. See the shell plating going. There goes the double bottom frisbeeing off. And the stern's falling through. So now the stern's falling aft end down. And we see the spiraling. Here comes the bow. Bow is falling in a stable position, and it hits. Yeah, boom. It kind of breaks its back, and we see the hydraulic outburst and the downblast effect. Let's see the stern. We see the shell plating blowing off deck.
Okay, so as we could see, as the compartments in the Titanic filled with water, the bow became more dense. The result of this was the bow sinking below the waterline and eventually breaking off. Okay, so some things we can think about that we learned today that relate to our everyday lives would be swimming, for example. We are able to go swimming in a swimming pool because our density is just barely lower than the density of water. Another thing would be party balloons. We can fill those up with a low density substance, which is helium, and that makes them able to float. Similar to that would be a hot air balloon, which are designed to have the same density as air so that they can fly. Alright, so that helps us relate our lesson back to our everyday lives, and thank you so much for watching.